Lesson 28, Triangle Congruence, SAS. So before we go over what that means, we're going to do a couple definitions. The first one is what's called an included angle. An included angle is an angle that is between two sides of a polygon. So it's the angle formed by two adjacent sides of a polygon. So if we're going to draw a polygon here, let's call it A, B, C, D. We could say that angle C, let's see, where should I write it? I'll write it over here. Angle C is the included angle of side BC and side CD. So if you take those two sides of the polygon, BC and CD, together, they make the included angle, angle C. So I'm just going to ask the question, what two sides would angle A be the included angle of? BA and AD. You got it. The next one is the included side. And the included side is the common side of two angles. So referring to the figure above, side AD would be the included side of angle A and angle D. So let's see, segment AD is the included side of angle A and angle D. So whenever we're using side angle side congruence postulate, the angle has to be included on the two sides, between the two triangles. So the side angle side postulate states that if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles will be congruent. So instead of writing that all out, we're just going to draw a picture. So if we have a triangle ABC and another one that looks very similar to it, DEF, and this side's congruent to that side, angle D is congruent to angle A, and AC is congruent to DF. Then triangle ABC will be congruent to triangle DEF. So you have a side, an included angle, and the other side of that included angle congruent to another set there. So we're going to do an example of proof that you would use the SAS postulate in. So this is just an example. We want to have a given. So T is the midpoint of segment KR, and angle KTP is congruent to angle RTP, and I'll draw a picture with that too. And we want to prove that triangle KTP is congruent to triangle RTP. So we have KPR, we have T, that's the midpoint. KTP is congruent to RTP. So we want to prove that the two triangles are congruent. That is a P. So we have statements, reasons. We'll start with the given. So T is, number 1, the midpoint of KR and angle KTP is congruent to angle RTP. And that was given. 2, so we think about what's given, and we can say, we can look at midpoint. Definition of midpoint is that the two segments that are formed will be congruent. So we can say that the segment KT is congruent to segment RT. We want to make sure we keep them in the right order. So what I do is I'll look up here at this triangle and say KT, well, it should be RT. So those two are congruent. That's just by definition of midpoint. Both triangles have this segment PT in them. And by the reflexive property, it will be congruent to itself. So we can say that PT is congruent to itself by the reflexive property. So now we have a side, an included angle, and another side of two triangles. So by the SAS congruence postulate, the two triangles are congruent. So that's the end of the lesson.